So we're looking at a problem in which we have a rational function. This is from my math lab. 27725, and in parentheses x minus 14 divided by x squared minus 9, and then minus 7x. Models the number of arrests. So this is a number per 100,000 drivers. For driving under the influence of alcohol as a function of a driver's age x. X is age. So when I read a problem, a word problem, I always read and take notes, and then come back and make sure that I didn't forget anything. Okay, so graph the function and they give you specific viewing window. Did you have any problem with that?
No.
No. Question. Okay, use the zoom and trace feature of the maximum function feature of your graphing utility to find the age that corresponds to the greatest number of arrests. How many arrests per 100,000 drivers are there? Okay, so basically only one we need to do is to put in the graphing calculator and determine the maximum, where the maximum is. Okay, perfect. So we are given, I'm just going to copy this for everyone to have it, 0, 70, and 5. This is the x, minimum, maximum, and the unit. And 0, 420, minimum, maximum, and the unit. So that's what we're going to do with the graphing calculator. My apologies. My apologies. My apologies. Sorry. Okay, so in y equals, we have to copy the function. So in y equals, for the numerator, 27725 in parentheses x minus 14. And close the parentheses, and the denominator is x squared minus 9. And then completely outside minus 7x. I think you probably forgot to put minus 7x. You did?
Yeah.
Okay, so in the window between, they say 0, 70 with a scale of 5 and 0, 400 with a scale of 20. Okay, so then let's look at the graph. Okay, so we see the maximum. So this is by 20, right? From 0 to 400. No, from 0 to 70 by 5. So 5, 10, 15. So between 15, and this is 70, between 15 and 60. So second and calc, I want a maximum, which is 4. And I'm going to say between, or I can drag till it passes the minimum on the left, the maximum on the left, and then on the right. And I think it probably did it. Yeah, of course, it considers, that's not what I meant, but this calculator has a mind of its own. So second and calc again. So I want the maximum, which is 4. I want it between that. That's correct. And now make sure it passes the maximum. And yes, that's my right bound. Yes, give me the maximum. 24.17, comma 321.02. And be careful with whatever number of digits they want.
Because when I put in my calculator, it says 23.8. So that's what.
Yeah. Is it clear now? Is it clear?
Yeah.
Okay. So just copy it down. What we got. So and you enter. Was this the only question?
Yeah, I know someone. What do they mean by upper, like upper half of the domain and the lower half of the domain?
The graph shows a rapid increase as x approaches the maximum in the upper half of the domain. So if the domain is between 0 and 10 as an example, the upper half is you look between 5 and 10. The lower half you look between 0 and 5. The upper half of the domain and the lower half of the domain. Good. Other questions? Very good question. Thank you. Anything else? Anything else? Okay, so let's go back. Would you like to go back to any exponential equation before we move on to log equations? Is that a
I
yes?
didn't get one.
I'm sorry?
I didn't get one.
How could I have forgotten? I forgot you here. I'm so sorry.
Thank you.
You're welcome. Let's start right now. Okay, good. So would you like to go back to another exponential equation? And the answer is very simple. Is it a yes or is it a no? Tim? You need this because, yeah. Okay, so here's where we are again. So we are finishing hopefully 4.4 today, and then we... I'm sorry. So here's where we are today, 4.4, and we're going to start hopefully 4.5, and then we have these 5 sections left before we take test 3. Okay, so would you like us to go back to another exponential equation? The answer is yes or no?
Yes.
Yes, okay. So would you like to choose or would you like me to choose? If you'd like me to choose, I'm going to choose 44. 44 on page 514. E to 2x minus 2e to x minus 3 equals 0. And with this, we really covered almost everything that we can think of in exponential equations. Okay, so what type of equation is it? Very good, because the variable is at the exponent, the level. Right, it's not a linear, it's not rational, it's not absolute value, it's not radical. Of course, it's exponential. Okay, what would you recommend we do here? Normally, you would say move 3 to the other side and apply log to both sides because we cannot apply log to 0. So in this stage, that would not be possible. Here's why. Okay, let's say I move this term to the other side, but there is no log applied to a sum or difference. So we will be stuck. So if we move 3 to the other side and we try to apply log to a difference, remember there is no log applied to a difference. We have 3 properties. Log applied to a product, log applied to a ratio, and log applied to a power. There is no such thing as log applied to a sum or difference. So this doesn't work. Now let's look at the equation as a whole one more time and say, I remember something from a long time ago, and we used that method. What method? No, I would not complete the square on this. Something else that we know from a long time ago. In form. I agree. How? Yes! I realize that this can be denoted by y only if what? Only if this can be denoted by x and y in the same equation. We don't want that. Y squared, which means y squared minus 2y minus 3 equals 0, but only if it's there. I cannot make it happen if it's not there. But is it? So when I square e to the x, what do I get? Copy the base. What happens to these two? Right. So therefore, this is indeed y squared as long as I call this y. And this is easier to factor. How do I factor this? Yes?
Y plus 1, y plus 3.
Excellent. So there are 2 options in y. What are the options in y?
Y equals -1.
Great job. Very good. But this is not done because we determined a solution in y, but who cares about y? We do because it helped us solve the equation, but the answer must be given in x. So what? So we have now two more equations to look at. Can anyone give us the first one?
-1 squared minus
E to the x equals -1. And can anyone give us the second equation?
e to the
Yes?
x
Yes?
negative, no, 3.
Equals 3. Very good. These are the two equations we have to solve. Okay, let's start with the second one. How will you solve the second one?
Place x 3.
How will you solve the second equation? Very good. We apply natural log to both sides. So what do we have on the left-hand side when we apply natural log to both sides? X goes in front as a factor. How much is natural log e? Natural log e is? How much is natural log e? Very good. Equals natural log 3. Please remember, natural log e is 1 indeed. E raised to the first power is e. Now let me know if you have questions. Let's solve the second one. What happens now?
X apply natural log to both sides of the line.
I can't. Because the right-hand side is a negative number. So if we graph this, remember we had a situation similar to this. Let's graph it again. That's okay. E to the x is a base greater than 1 or less than 1? Yes, which means the function is always increasing on all its domain, and it crosses at 1. But now when I graph the other side, which is y equals -1, here's the graph. So this is the graph of y equals x, and this is the graph of the other one. Where will they meet? Never. So I'll say that's not possible. Here, no solutions. The left-hand side cannot equal the right-hand side. I cannot apply log to the other side. So the only solution is this. The only solution of the equation is x equals natural log 3. Oops. Good. Any questions? Any questions? Okay, the second half of this section is log equations. Log equations. We'll start with simple ones and we go to more complicated. Ready? Here's the first one. Log base 2 of x is 3. Every time we solve log equations, we have to choose one or the other of the following methods. It doesn't matter which one you choose, but you have to choose one. You either say, I commit myself to check solutions in the original problem, or the second option is, which I prefer, but you don't have to, is state domain. I prefer the second one. It's easier for me because sometimes I forget to check solutions. So that works for me. You can say, no, I don't like stating domain, although you will have to at some point. But I promise to go back and check one or the other. Okay. So can anyone give us the domain of this function? What do I have to write in order to find the domain of this function? This is a function, it's log base 2 of x. What do I have to write in order to find its domain? Say it again. No, the domain. How do I find the domain of this function? How do I find the domain of this function? It's in your notes. We started with this kind of problem last time.
Change it to
That's for solving. That's for solving, yes. But if I have this function and I'm asked to find its domain, what will I write? The first problem last time. We just went over the notes from last time. Yes?
3.
Say it again. Yes, of course. X must be greater than 0. This is indeed the domain. 0 to infinity. In other words, what I'm saying is if I don't find a solution greater than 0, it cannot be accepted. Would you agree? Yes?
Yeah.
Perfect. Now we are ready to change it. Remember, I have to choose one or the other. I don't like to choose this, but that's me. I like to choose this. It's a good practice because one of the questions will ask you to find the domain if you really don't want to. So then, how do I change this log equation into an exponential equation? From the base, counterclockwise, to the third power, raised to the third power equals x, which means x equals 8. It's a number greater than 0. We're done. Where's Brian?
Yeah, where is that?
Okay, I just had to take attendance too. Okay, perfect. So let's move on. The next level, same page. We continue on page 515. And let's say 60. On page 515. Log base 2 of 4x plus 1 equals 5. We want to state a domain. Please state a domain for me. Do not solve. Just tell us what to write in order to solve it, to find a domain.
0, x is greater than 0.
Say it again.
X greater.
This log is not applied to x. What is this log applied to? Very good. So what do I have to write?
4x greater than 0.
Very good. And greater than 0. 4x greater than -1. X greater than -1/4. So if the solution is not a number greater than -1/4, then we would not accept it. Perfect. Okay. So now I'm ready to change this, convert it into an exponential equation. Please tell me how.
To the fourth x.
2 counterclockwise to the fifth equals 4x plus 1. So that's 32 equals 4x plus 1, or 31 equals 4x, or x equals 31/4. Is this a number greater than -1/4? If you say yes, then I will say yes. Accepted. If you say no, then I'll say no. Very good. Let's look at 68. Yes, please. Alex, you had a question? Go ahead. Yes, please. Go
What
ahead.
do you mean by no?
It's a number greater than -1/4, so there is no question there.
What you just said. If you say
No, I said if you say it's not, then I'll have to say that the solution doesn't exist. But since you said yes, the solution existed, because that's the correct answer. It is greater than -1/4. Good. 68. Same page. Log base 6 of x plus 5 plus log base 6 of x equals 2. What type of equation is this? I know it's a silly question, but I just want to hear you say it.
Log equation.
It's a log equation. Very good. Awesome. Excellent. Very good. Can you please tell me what to write for finding the domain of the first one?
X plus 5 is greater than 0.
Very good. Excellent. X plus 5 must be greater than 0. Can you please tell me what about the other one? Very good. You must state the restrictions before you condense. The restrictions must be stated on the raw equation. So then when I solve this, I get x greater than -5. When I solve this, I have greater than 0. I have to intersect. So then x must be greater than. One goes from -infinity to, from -5 to infinity, and the other one goes from 0 to infinity. Where is the intersection? To infinity. Very good. So if the number that we get, or numbers that we get, are not greater than 0, we'll have to say, sorry, no solutions. Good. Now we are going to condense. That's why in the previous section, we looked at condensing and expanding. So just tell me, how would you condense the left-hand side? We have a sum of two logs in the same base. How do we condense? Log base 6 applied to
X times x plus 5.
excellent. X times x plus 5 equals 2. If you want to put brackets, you can put brackets. It's log applied to that product. So now please tell me how you change this into an exponential equation. Yes, very good. 6 squared equals, and let's distribute. X squared plus 5x. And we know that 6 squared is 36. So then we have x squared plus 5x. And can anyone tell us what type of equation is this? It is quadratic. What do I have to do? What do we do with all quadratics? Yes. X squared plus 5x minus 36 equals 0. I'm hoping that it's factorable. If it's not factorable, I can use what? The quadratic formula. Very good. Yes? X minus? We can't get stuck on this one, can we? Please say no. It's right there.
So yeah, it's going to be x minus 5, x minus 4, x plus 9.
Awesome. So then we have two x values.
X plus 4.
was
Okay.
close. Because we did.
I don't know if it's gonna work.
So now let's go back to our restrictions. What did we say?
It cannot be negative.
Exactly. Because the intersection of the two domains, the common domain, in other words, so we can add them, was this. Which means which solution is accepted, which one is not.
Or is accepted.
Yes, and I'll say no. You don't have to go back and check because we stayed the domain. Well done. Okay, let's take a look at 76. We're still working on log equations. In 76, log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 equals 2. Okay? The first the first function needs domain, which is, what do I have to write?
X is greater than
So let's write x minus 3 greater than 0 for everyone to see. The middle one, what does it need?
X greater than
The last one, what does it need? Yes. You understand we are finding the common domain. We cannot add these functions if they don't have a common domain or subtract them. That's what we're doing from chapter 2, basically. Good. So the first one says x greater than 3, then x greater than 0, then x greater than negative 2. We must intersect. One starts at negative 2 to infinity, the other one from 0 to infinity, and the last one from 3 to infinity. Where is the intersection of these three? One more time. From negative 2 to infinity, from 0 to infinity, from 3 to infinity. So x must be greater than? Okay, so let's say we don't see that. That's fine. So let's graph it then. From negative 2. From 0. And from 3. I need 3 colors. I need orange, pink that you cannot really see, and black. All 3 at the same time. The common domain. Right. The 3 colors are right here. Only between 3 and infinity. So if the number or numbers that we get are not greater than 3, they cannot be accepted. Is this clear? Yes? Any questions, please? Stop me if you have questions. I'm always concerned when students don't ask questions. I don't know. Are they following? Do they need more time? So please tell me. Ready? So let's go back to the equation and please tell me, how will you condense the left-hand side? I had the blue. I thought I had the blue. Maybe not. So please tell me how to condense. Oh, here it is. Tell me how to condense the left-hand side. And remember what we talked about last time. And we said, if log has minus in front, its quantity is coming from where? Right. If it has plus in front, its quantity is coming from? Good. So please tell me how to condense this then. They're all log in base 2. So x minus 3 over, that's it. And now we want to change this into an exponential equation. Do we all understand this condensing part? Alex? Okay. So then please change this for me into an exponential equation. Yes. Equals x squared minus 3x over x plus 2. So then this is 4 equals x squared minus 3x over x plus 2. Now I have to dig deep. What type of equation is this? Because it's not linear, it's not absolute value, it's not quadratic, it's not exponential, it's not log. But what is it? It is, how do we call it? Say it again. I heard 3 answers and I didn't actually hear any. So what is it? Okay, I'm on strike. If I don't get the answer, excellent. You probably said it, I just didn't hear it. Sorry, of course. Of course, it's rational. It has a ratio, it has x in the denominator, it's a rational. Very good. And the rational equation, and I want to give you a little hint. What does the hint say to you? Thank you very much. Great job. Indeed. So 4x plus 8 equals x squared minus 3x. Now I'm going to ask again. What type of equation is this? Quadratic. So then we have x squared minus 7x minus 8 equals 0. And we have to set it equal to 0 as we just did. So now what? Perfect. So let's factor this.
X minus 8.
Perfect. And now please give me 2 x values. What do we conclude?
8 is yes, and 1 is
Yes. And this one is not. So the only solution is x equals 8. Very good. Well done. Okay. 84. Are we getting a little bit better at solving these equations or not? Yes? A little bit better? Okay, perfect. So I said 84. So log x plus 7 minus log 3 equals log of 7x plus 1. Very good. Don't touch anything, don't do anything. We need 2 domains. One for this and one for that.
x plus 7 is greater than 0. 7x plus 1.
Excellent. X plus 7 must be greater than 0 and 7x plus 1 must be greater than 0. The first one is greater than negative 7 and the second one is greater than negative 1 over 7. So the first one starts at negative 7 going towards infinity. And the second one starts at negative 1/7 and going to infinity. We want the intersection.
7, negative 7.
So from negative 7 to infinity, the other one is
Oh.
from negative 1/7 to infinity.
Negative 7.
Very good. So if the solution is not a number that is greater than negative 1/7, we'll say, no way, this is impossible, no solutions. Perfect. Now we're ready to condense the left. Leave the right-hand side as is. And just tell me how to condense the left-hand side.
7x plus 1 over.
First of all, I have to copy log. Without log has no meaning. Of.
Log of x plus 7 over 3.
Excellent. Do we all agree with this? So it had negative in front of log 3, therefore that quantity has to go or come from the denominator. In this particular case, there is no need to change the equation into an exponential, the log equation to an exponential one. Here's how we think. Do not cross out anything. We're not simplifying anything. We're thinking. We have two logs in the same base that are equal. What has to happen to these quantities? They must equal each other. That's all you need to do in this case. So x plus 7 divided by 3 equals 7x plus 1. And this is what type of equation?
Trash.
It doesn't have x in the denominator.
Oh.
It must be linear.
That linear one don't have the x.
Let's multiply everything by 3. So we have x plus 7 equals 21x plus 3. And take it from here. I'm going to move 21 to the left. So I get negative 20x. And I'm going to move 7 to the right, and I get negative 4. So therefore, x equals 1 over 5. If 1 over 5 is a number greater than negative 1/7, then the solution is accepted. If 1/5 is not greater than negative 1/7, then the equation has no solutions. What would you conclude?
It's good.
Yes, it is good. Very good. I would like to look at 62. And then one more I have in mind. 62. 6 natural log 2x equals 30. Ready?
Here.
Okay, I want to state the domain, please. What do I have to write first?
Let's
Yes. 2x greater than 0, which means x greater than 0. We divide both sides by 2. Excellent. Good. So let's look at the equation again and decide what to do, because it's not completely cleaned up. And it can be cleaned up. What will we do? We will
Oh. What do you do? Condense. Do it.
There's only one log I can condense. I can condense when I have at least 2 logs, but this is only one. So what do you think we have to do first, for sure?
It's going to be 2x.
Nope. We need an extra step to clean it up. It's not completely cleaned up. Yes? How? I cannot move, it's multiplied, but I can do something else to remove it, which is, since it's multiplied, what should I do to get rid of it? Very good, awesome, that's all I want you to say. So natural log 2x equals 5. Now this is completely cleaned up, and now I can change it into an exponential equation. You understand? You cannot make that change before you get rid of the number in front. So then how do I change this log equation into an exponential one? What is the base? I don't see a base here. What is the base?
10.
LOG has base 10. Natural log has base e. E to the 5th power equals 2x. So x equals e to the 5th over 2. Is this number greater than 0? Good. So then we'll say yes. This is the correct solution. Okay, well, let's also look at 92. And then I would like to look at a word problem. Natural log x minus 5 minus natural log x plus 4 equals natural log x minus 1 minus natural log x plus 2. So long that I ran out of room again. I see 4 functions. I need 4 restrictions, please.
X minus 5 is greater than 0.
Very good.
X plus 4 is greater than 0.
Very good.
X minus 1 is greater than 0.
Very good.
It's greater than 0.
So
Thank you very much. This one means greater than 5. This one means greater than -4. This one means greater than 1. And this one means greater than -2. Graph them if you need to, and give me the domain. Yes, from -4, from -2, from 1, and from 5. Indeed, 5 to infinity or just x greater than 5 is good enough. That's where both of them, that's the interval where 5 to infinity, where all 4 logs exist at the same time. Perfect. So let's condense the left. Let's condense the right separately by themselves. The left-hand side, please. Yes?
x minus 5 divided by x plus 2.
Excellent. The right-hand side.
So x minus 1 divided by x plus.
Perfect. Very good. It has minus in front. It's coming from the denominator. It has plus in front. It's coming from the numerator. Very good. Awesome. So now I'm thinking, I'm not doing anything else. Don't cross out anything. You're not simplifying anything. We're saying this. 2 numbers are equal, and they have logs with the same base. What has to happen here? They have to be the same. There is no other way. So x minus 5 over x plus 4 must equal x minus 1 over x plus 2. What type of equation is this? Yes, it is a rational equation. What are we going to do? It's a proportion. So we're going to cross multiply. So x plus 2 times x minus 5 will equal x plus 4 times x minus 1. Can anyone give us the left-hand side of the equation, of the equal symbol? X squared. So plus 2x minus 5x, which is negative 3x, and minus, excellent. Can anyone give us the right-hand side? X squared minus x, but plus 4x, plus 3x, minus, very good. This is a quadratic, but look what happens. Nice. I move negative 3x, so I have a negative 6x. And I move a negative 10, so I have a 6. So then x equals negative 1. No solutions. Not acceptable. It's not a number greater than 5. So it cannot be accepted. The equation has no solutions.